Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. Good morning, good evening, or good afternoon. My name is Ida DeBuri, and I'm from the ITU. I am pleased today to present our session, Neurotech is Coming. Stay tuned for an expanded AI ethics landscape. We encourage you to ask questions and say hello in the chat box. We will answer some of the questions at the end of the session. So without further ado, I'm very pleased to introduce our two speakers today, Francesca Rossi and Sarah Berger. Francesca and Sarah are both at the IBM TJ Watson Research Lab, where Francesca is an IBM Fellow and the IBM AI Ethics Global Leader, and Sarah is a research staff member. Over to you, Francesca and Sarah.
All right, so thank you, Ida. Good morning, good afternoon, good evening to everybody. Thank you so much for having us. It's a pleasure to be here, even if it's virtual, and we really appreciate it. So today, Dr. Francesca Rossi and I, we're going to be talking to you about emerging technology called Neurotech and how it's going to impact and expand the AI ethics landscape. All right, so what do we have in store for you today? So we're going to first introduce neurotechnology and neurodata. So what is that? And we're going to give you some examples, go through the state of the art, this type of thing. And then we're going to move on to ethical, legal, and social issues in this space, so neuroethics. Then we're going to go into artificial intelligence, talk a little bit about the applications, the evolution of the field, as well as AI ethics. And that's where we're going to be comparing ethical issues between neurotech and AI. And then we're going to finish with some key takeaways. So what can you start thinking about now as either AI users or as practitioners, with some time, of course, for questions. So let's start at neurotechnology. So neurotechnology, or neurotech for short, it's any technology that collects, interprets, infers, modifies neurodata. And that's data generated by the nervous system. So some of you may have heard of a brain-computer interface, or a BCI. That's one example. But here I really want to call your attention to the idea that this data, this neurodata, is generated by the whole nervous system. So that includes the brain, it also includes the spinal cords, and it also includes the peripheral nervous system. So those are the nerves that are going to and from our limbs and our organs. And neurodata can also take many forms. So this can include, but it isn't necessarily limited to neuronal activity, neural tissue samples, or even proxies of this activity. So things like blood flow or receptor binding. Neurotech is what we call an emerging technology. So what does that mean? That means that it's tended to be characterized not only by its novelty or its immaturity, but also by its potential for growth. And what I mean by that is its growth in terms of scale and also in terms of public interest. Emerging technologies are also characterized by their ability to potentially transform multiple aspects of human life and even society at large. And importantly, because they are still emerging, right? They carry with them a lot of different unknowns. And that means that how they impact society is really, it remains uncertain. And neurotechnology may have or will have all of these qualities. So let's start with how do we typically talk about neurotech? And so neurotech typically is classified along two different dimensions. So I'm showing the level of invasiveness on the top and then the capabilities on the side. And invasive neurotech involves electrodes, devices, things like this that are implanted inside of the body. Whereas non-invasive neurotech, it really uses wearable devices that sit on the surface of the body. It can be on the head, it can be on the arm, etc. And then in terms of capabilities, we have neurosensing tech, which essentially it reads neurodata by collecting it, monitoring it, interpreting it invasively or non-invasively. We have neuromodulating tech. So that essentially writes or really it changes neural data invasively or non-invasively. And then you can have this combinatorial or bidirectional neurotech that can both read and write neurodata invasively or non-invasively. And here I just want to pause and just touch on a couple things. So first of all, this is only one way of categorizing this. So you might hear others in the space make different distinctions. And really that's because the field is still trying to come up with standard language for some of these things. This is just a common one you're going to hear. Another thing is that the level of invasiveness that we're talking about on this slide is more about like a medical distinction about whether something requires a surgical procedure or not. So it doesn't necessarily correlate to how safe something is, or in other words, physical invasiveness, it does not dictate perceived invasiveness or psychological, mental life invasiveness. Another thing is that these are just a handful of examples. There's a lot more we could put on this little table. There's a lot more being developed. And the last thing I'll just note again is that the location of these interfaces, right now this picture is really kind of concentrating, I think, a little bit on the head, but the location of the interface is also less important. So again, devices can be worn on the wrist, they can be worn on other parts of the body to really pick up on neural data and neural signals. So what is the state of the art in neurotech? What's possible now? And before getting into this, that question I'd like to ask everybody who's watching this. What do you think is possible? So my, I guess, rhetorical question for you is, which of the following 4 items I'm about to put on the screen, which ones represent neurotechnologies that already exist in some capacity? So they're science fact, versus those that do not yet exist. They're still in the realm of science fiction or fantasy. So the first one is reading and translating or mobilizing our intended thoughts or actions. The second one is interpreting and visualizing our mental imagery, things like our dreams. The third one is changing our ongoing sensations and perceptions. And then the fourth one is sharing emotions and memories directly brain to brain. And I'm just going to give a dramatic pause here and have everybody think about it for just a few seconds. So which ones are in the works versus science fiction? And then I'm just going to cut to the chase and say that it was a trick question. And really all 4 of these, they represent neurotech capabilities that exist in some form today. And I want to be really careful here. I want to be really intentional to say that they exist today at different levels of maturity, of different levels of accuracy, of scale. And that could be from robust demonstrations in basic research with lab animals to preclinical research in humans, all the way to commercial devices on the market or being used today by people in clinical settings. So for the sake of time, I can't go into more detail here, but I promise I'm going to return to each of these in a little bit. So given that, what are some current and future applications? Neurotechnologies, they represent this area of innovation that has this potential to positively impact a lot of different market sectors. And so again, many different aspects of human life. And I'm showing a few here. I'm sure I'm missing some. And I think, the healthcare and therapeutic space may be an obvious one to everybody, but we're also seeing an interest in development and use of neurotech in spaces like marketing, entertainment, defense, and even law. And so I'm going to touch on 3 of these to just give you all some sort of concrete examples of neurotech applications today. So neurotechnology found in the healthcare therapeutic space, it's already really highly regulated due primarily to safety concerns. Again, since many of them are invasive, they go in the body. Applications are often used to restore or improve sensations and perceptions. So this is to help patients regain, let's say, functional mobility. Or in the examples shown here, they're used to treat like specific illnesses. So we have deep brain stimulation on the top for Parkinson's disease, and we have spinal cord stimulation for chronic pain on the bottom, both of which are neuromodulatory. So again, that means that they change neural activity. We're also seeing an increase in non-invasive with direct-to-consumer or private, maybe like direct-to-company neurotech. So in contrast to the therapeutic space, these neurotechs might have very little, if any, regulations associated with them, even though they have potentially wider reach and less specific use. So 2 pertinent neurosensing examples I'm showing here in the workplace and also in education. So wearable neurotech is now being used in industrial and factory settings to monitor workers' fatigue levels to try to prevent accidents, for example, like with heavy machinery. Similarly, we're also seeing wearable neurotech being deployed and tested in classroom settings. So used, for example, to monitor students' attention levels during lessons to provide feedback to teachers and parents. And so those represent the things that are happening now. And I want to also kind of give a moment to show you what neurotech might have, what it might do in the future. And I was kind of alluding to a few of these before. So on the left, we're showing neuroprosthetics and neurorobotics. And both of these can be invasive or non-invasive. They're usually being created to enable individuals who might have like movement or motor difficulties, say because of something like ALS or a spinal cord injury, usually to help them regain movement, but also to help individuals with missing or injured limbs restore sensations they once had. So things like touch or the feeling of temperature. On the right, we're showing how neurotech is also being utilized for different forms of, I'm calling it communication. So on the top, you see 2 participants who have ALS and they can no longer speak. And they're learning how to type on a keyboard with their mind. So the device is translating neurodata into text, and this is intentional. They know they're doing this. In earlier stages of research, we're also seeing attempts to translate mental imagery into physical imagery. So I talked about this very briefly earlier. So from dreams or thoughts, we're also seeing attempts to transfer and share things like emotions, memories, and sensations from one animal to another. So these include things like sharing a memory of a maze or sharing a previous experience of fear or even of pain. So these kinds of research are really about decoding, sharing, and even changing neurodata. So what is neuroethics then? And I think in order to really talk about this, I want to return to the examples that I started with. So how does the fact that these technologies either exist now, they're being worked on, or they're likely going to be mature in some form, available in humans for many of us within our lifetimes? How does that make everybody feel? So are you intrigued? Are you excited? Are you concerned? Is there something else? Now, what happens if I tweak just a few words here and there? So how would you feel, for example, if I changed reading our intended thoughts or actions to become reading private thoughts or actions that maybe we wouldn't want to share, or subconscious thoughts or actions that we ourselves might not be aware of or privy to? Does that change how you feel about, these kinds of technologies? Or what if I changed visualizing our mental imagery from being for basic research to instead used for improving communication on the one hand, or as lie detection, evidence in the court of law on the other? Does it matter more to you if manipulation of our sensations and perceptions is done by the medical industry, or if it's done by the entertainment or gaming or social media industry, or even the military? Like, which are you more comfortable with and why? And then finally, what if instead of simply sharing emotions or memories, we're able to delete certain memories or create new or false ones? And are there any new issues that arise in your head when you're just thinking about this? And to throw even more variables into the equation, right? Like, how does all of that change when we ask who it's being done to? So I hope as you kind of see me asking more and more questions, or just changing a few things, you can kind of realize that the context of creation and the context of use, they significantly impact how we approach and think about neurotechnologies and neurodata. And in every case, we have to really ask ourselves key questions like, what neurodata is being collected? What's its intended use? Who's using it? What's being done to it? How are they going to go about doing this? Who is it for, right? And this is really where neuroethics comes in. So neuroethics is the study of ethical principles, ethical implications related to the collection and usage of neurodata, the creation or application of neurotech, and also just the practice of neuroscience as a field generally. And importantly, because neuroethics has so many applications to it, it's more than just the study of these implications. It's also a place for what we call applied ethics, or ethics in practice. And applying and operationalizing neuroethics, it can take a lot of different forms. It can look like a lot of different things. It could be from changing how R&D is done, to creating new standards and policies, to updating laws, regulations, maybe even rights, to educating different parties, engaging with different publics, getting different public debate and input, right? So ethics is very broad here. And so I want to take a step into a little bit more specifics and just go over some of the ethical, legal, and social issues, what is often referred to as ELSI in neurotech and neurodata. So I think, right, that we can kind of see some of these applications are already kind of raising some issues that maybe we don't feel comfortable with. And I'm showing a few really big ones on the screen here. I want to just note that these are not exhaustive. We did not come up with these ourselves. They're not mutually exclusive. It's just an overview. So some of these challenges that I'm showing here, they're common. And what I mean by that is that we face them, or we have to think about them often, and often with other technologies. So concerns like security, accuracy, environmental sustainability, those things on the top. And I highlight this overlap because it suggests that some existing technical strategies or some existing governance models or mechanisms, they might be able to be reused or applied or adapted to neurotech applications to mitigate some of these concerns, and that's a good thing. However, there are other issues which, although not necessarily unique, but just due to neurotech's complexity or neurodata sensitivity, they might represent concerns that are heightened or intensified or expanded in some way. So things like mental privacy, human agency, identity. And if that's true, these issues might indicate that we need to actually update existing regulations or policies, or maybe create new forms of governance, to address these concerns. So Francesca is going to be touching on this more later when she compares AI ethics to neuroethics issues. But for now, let me just again present you with a few more questions. So if neurotech devices, if they can eventually really infer what we are thinking, feeling, or intending to do, how do we prevent things like unauthorized observation or unconsented interpretation? If neurotech devices can modulate activity, how do we ensure things like protection from coercion or manipulation, or maybe unwanted changes in perceptions or experiences of our body or of ourselves? Where do we need to update informed consent processes and standards? Are the ones that we have now good enough to be able to account for these issues? And then what are implications for the environment, particularly with devices that might contribute to things like e-waste or energy consumption? So these are just kind of a bit more of like the flavor of what we're talking about here. But I do recognize, though, that these are all very high level, like principle level concepts. So I want to give even a little bit more concrete examples of some ethical issues. So if we return to that therapeutic neurotech space, so if we turn to here deep brain stimulation, so many of its components and its requirements, they're expensive. They're highly specialized, and in places where, quality or affordable healthcare really isn't guaranteed to all citizens, this really raises questions about what fair access to treatment and fair access to well-being might look like. There are also really genuine concerns about continuity of care. If devices that people maybe depend on become obsolete or become discontinued. And additionally, even if the tech is highly regulated, maybe due to safety needs, because it's invasively modulating or writing neurodata, any changes to the patient's behaviors are really hard to see. So if, for example, they suddenly don't feel like themselves, or they suddenly have some sort of new symptom or new side effect, it becomes really difficult to dissociate, the changes due to choices or lifestyle, or the changes due to the underlying disease progression, or are the changes due to the device malfunctioning. And so when you can't decipher that, it makes accountability for things like agency, and identity even harder to assess, harder to mitigate. And then on the other hand, when we have like direct to consumer or private devices, maybe those like used in workplace neurotech to monitor fatigue, what happens when they are not developed and tested with a variety of people? So like those with different hair types or different head sizes. What if they're not tested in people with non-normative neurodata? So what might happen then is that the neurodata collected is not necessarily representative. It might be especially noisy or inaccurate because it doesn't fit well on a person's head. And all of these things in turn can lead to misinterpretation. It can lead to discrimination. In the context of work, like I'm showing here, this could affect a person's financial livelihood, right? And then moreover, with these types of things, since neurodata collected might contain multiple kinds of information outside of fatigue or attention, right? We're still learning about what these signals are doing, what are the boundaries of these things. It opens up this door to potentially like use this information for other use cases, or monitor, in this case, workers in other ways they might not have agreed to or even understood in the first place. And so that obviously has implications for things like transparency and mental privacy. And so, we've been talking a lot about neurotech, and we've been talking a lot about neurodata, neuroethics, but we're at an AI for good talk. So what does all of this have to do with AI? Why are we telling you about this? And it's because neurotechnology rarely operates alone, right? It's usually intersecting with requiring other technologies just to function. So some might be obvious, right? If you're wearing an interface, that's going to require material sciences, hardware, possibly also electrical, maybe even chemical or pharmaceutical components. Neurodata is also collected and transferred and stored, so that requires servers and cloud and internet, how somebody collects neurodata, how this data is protected. This requires different kinds of sensors and security software. But neurodata itself, it also requires a lot of processing. It's very noisy. And so both pre and post-processing often rely on artificial intelligence and machine learning. And this becomes even more apparent and more needed as the data sets become larger, as they become more complex, more multimodal, and also as data is collected less in the lab and more at home or in non-lab settings. So now I'm going to turn it over to Francesca, who's going to talk about AI ethics, and then start intersecting AI ethics with neuroethics.
Thank you, Sarah. So we can go to the next slide, and we'll start making more about the connection between neurotech and AI. So I'm sure that this audience doesn't really need to know what AI is or need me to tell you what AI is. But just in case there is somebody that is not very familiar with the concept, this is a very, very brief and oversimplified representation of the history of AI. So AI is a research field and a technology and a science that started long time ago, not just in the last few years, like somebody seemed to think, and started more than 60 years ago with algorithms that try to embed and code into machines intelligent ways of solving problems. And some of these ways were thought and defined by human beings, researchers, developers, that first they were thinking about the recipe, about the algorithm to solve a problem intelligently, and then they were coding into the machine. And these were the first kind of AI that was machines that were created. Then in the 80s, the machine learning approaches that relied on the analysis, interpretation of data came about, and they are very similar, although of course much more advanced now, to the deep learning and the newer techniques that are data driven in AI and are responsible for many successful current applications on AI. And the reason why they were existing already in the 80s, but they were not supporting the widespread application of AI as we have now, is that these techniques need, the machine learning techniques need a lot of data to function well, and consequently also huge computing power to analyze and store and being able to interpret that data through the algorithms. So in the 80s, of course, we did not have a lot of data available. We were not connected. We didn't have social platforms. We didn't have the internet. And we didn't have much computing power. So the reason, one of the reasons why deep learning approaches and machine learning approaches are functioning so well is because now we have both of these ingredients that make these techniques work well. So over the years, you see this going from coding algorithms into machines to having machines learn their own way from data on how to solve problems. Although the initial kind of AI, as you see in these very simplified pictures, is still going on and is now being actually combined with machine learning approaches to avoid really sometimes the use of so much data, the need of so much data in solving the problem. We can go to the next slide, Sarah. So here is a very incomplete list of domains where you can find some AI applications. But basically everything you do online during your day is supported by AI, whether it's a digital assistant in your car or at home, or some travel or driving support like autopilot or assisted driving approaches, or ride sharing app, or customer care when you call your utility company to ask for some questions, or your bank and the chatbots that you talk to, or online recommendations for new friends, new online friends, new things to buy, new movies to watch, and so on. The media and the news with systems to place ads and to curate news, healthcare, analysis of medical images and recommendation of diagnosis or treatment plans, financial services like credit risk scoring, loan approval, fraud detection, and many others, the job market as well, and the judicial system for recidivism prediction. As I said, it's a very incomplete list. But here, yeah, go ahead, Sarah. In the next slide here, you can see that not only is used in everything we do online, but it's important to remember that it's used in many high-stake decision-making scenarios, like in the financial system that is really affecting our financial status, which is part of our well-being, the employment, so how people are given opportunities to find a job or to be promoted, or everything about, or to have a raise in the salary and so on. To admission to schools and education, to healthcare, and in general to all the operations inside an enterprise. So you see that is injected these AI techniques not only in everything we do online in our private life, but everything we do also in things that are very important for our life, for our well-being. If we go to the next slide, it's important to remember that AI as a technology and a science, as I said, is not done yet. So that's why there are so many researchers all over the world that are working to improve and advance the AI capabilities. And what are the limitations that AI has right now? Well, there are several, but here I just mentioned 3 of them. One is that current AI is not general, so it doesn't know how human beings know how to do. It doesn't know how to go from one problem to another one with just few more data. So although there are some attempts to go making it more broad rather than the so-called narrow AI. So for now, the AI is thinking about a specific problem and then finding data about that problem and finding a solutions, good solutions for that problem. It also lacks robustness and adaptability, which is linked to the thing that I just said, of being able to tweak the input a little bit and having the AI being able to adapt to that changed, modified input. Here you see a picture in the top part where you have a speed limit sign that in the top row, you see these 2 speed limit signs for 80 and 120 kilometers per hour that are correctly interpreted. But if you tweak them a little bit, and you see in the second row, they are the same speed limit sign, but with something that to the human eye you would still recognize it as the same speed limit sign, but with just some things between in the white part. And instead, the AI system that was used to make these experiments was misinterpreting both of them. The one on the left was interpreted as a stop sign, and the one on the right was interpreted as a speed limit, but with the different limitations in the kilometers per hour. So still, images, in this case, images that are very similar, they are interpreted one of them very incorrectly. So robustness is still, there is still a lot of work to do. On the picture at the bottom, you see that the amount of parameters that the neural network, the machine learning approach needs, and also which is proportional to the amount of data and computing power that is needed to have these neural networks work, is growing exponentially. You see that you have many of the so-called large language models that are being now developed to interpret text and resolve various problems about text, BERT and others. But you see on the one on the right, the GPT-3 has a much higher need of parameters and data and computing power. So there is issues also about whether in many domains there is availability of such huge amounts of data, and whether that data in that amount and the computing power is available to many companies or many who would like to build AI, or only to just a few companies. So environmental resources, needs, and also power imbalance because of that. If you go to the next slide. Okay, so we saw that there are a lot of applications, but also limitations, but there are also a lot of ethics issues. Here I just mentioned a few of them that maybe you have heard over the years. One is about an example of a credit card approval process that was shown to be gender biased. So to propose credit cards with different limitations of the amount that could be spent on the card, whether the owner of the card was a man or a woman. The second example is discrimination in the dynamic pricing of ride-sharing applications. The third one was an example of a recruitment software that was shown to be gender biased, so giving different opportunities to men and women. The next one is a chatbot that was released on Twitter, and that very soon exhibited a very racist and unacceptable behavior to text that was writing. And the last one was an unethical use of personal data. So these are just some examples to give you an idea, and I'm sure you have many others that you have experienced personally, or that you heard, or that you read on the media. If you go to the next slide, I will try to give a more comprehensive description of the AI ethics issues. So the first one is about data, because as I said, many of the successful approaches to AI are based on the availability of large amounts of data from which to that we can interpret, and then from which we can infer predictions, classifications, and so on. So data privacy and governance is definitely a very central, raises very central issues in the ethics of AI. The second one is fairness. With AI, we can make decisions or recommendations to human beings that are going to make decisions. So, and we would not like these recommendations or these decisions to be discriminatory between different groups of people, different ethnicities, different genders, different ages, and so on. So the issue of fairness in AI is very important. Of course, the AI is not fair or unfair on its own. Is fair or unfair depending also on what it learns from data provided by human beings, or what it learns from human beings making decisions during the development life cycle of an AI. But in any case, we would not like these AI systems to make discrimination. So AI needs to be fair, or we need to be transparent about the kind of fairness or unfairness or bias that is still there. The next one is about inclusion. And here, inclusion can be interpreted in two ways. One is that we would like the AI system, once deployed in a certain scenario, to not exclude people from the access to this AI service, or to the benefit that can come from using AI in that scenario. So AI should not increase the gaps between those that can use the technology and can benefit from it and those that cannot. But inclusion is also important when AI is created and developed, because it's also one of the most important ingredients in making sure that unconscious and biases of people developing the AI are discovered and are not injected into the AI that they are building. The next one is explainability. Some of the most successful deep learning techniques are kind of a black box, meaning that they are not really it's not clear to understand how the output, the prediction or the classification relates to the input that is given to these systems. So they are not explainable. And if we provide people with systems that are not explainable, then we run the risk of being used in an inappropriate way. Consider, for example, a doctor that is supported by an AI system that helps him or her make decisions in the healthcare domain, if this AI system is not explainable, then it's probable that this doctor either accepts without questioning what the system is saying and is recommending, or the opposite. It will reject the following what the AI system is telling the doctor, just because it doesn't understand why the AI system is producing that output. The next one is a very important issue about transparency. So given the complexity and the need to use AI in an appropriate way, it's very important to understand how it was created. So here, the developers' teams and the providers of this AI technology should work in a transparent way in communicating how this AI system was created, which tests were done, for example, to detect or mitigate bias because of fairness, and so on. So in order to ensure a more informed use of AI. The next one is accountability. Deep learning or machine learning approaches are based on statistics, and they always have a small percentage of error. So it's important to figure out upfront who is going to be responsible and accountable for the errors that will be made by these AI systems. Of course, in general, there's also the issue of social impact. At a very high level, AI is becoming very pervasive, and it generates very fast and very widespread modifications and transformations of our society, and also of the way we work in our society. So this impact on societies, the way we work, the way we interact with each other, the way we live our day, is really transforming our society a lot. And we have to figure out whether that's a transformation, intentional transformation, that it's aligned to the vision that we have of the future of our society. If we move to the next slide, you'll see that there are also some other issues here that are mentioned. And one is about human and moral agency. We would like this moral agency and in general agency to be retained by human beings. But this can, even if, and Sarah mentioned already some examples in the neurotech space, and so even if AI is not invasive in the sense that Sarah mentioned, it does not go inside our body, but it can still profile people and interact with people in a way to manipulate our preferences, and therefore impact on our agency, on the control that we really have on the decisions that we make. So that's an important issue that we will see is also connected and linked to the neurotech issues. Of course, AI, many people say that AI is just a tool. You can use it well or you can use it in a bad way. But this is not this is not true. The AI has to be built in a way that has the right properties, but it's also important to understand how we want to use it. So the use is also one aspect of these AI ethics considerations. And of course, one can use it for good things, like the whole topic of this initiative that we are talking about here. For example, for achieving and getting closer to the UN Sustainable Development Goals, or you can use it for things that are less beneficial to society, like mass surveillance, autonomous weapons, or others that can be considered. As I mentioned, there is also environmental impact issues because the current most advanced AI models need a lot of energy for training and deployment because of the need of huge amounts of data and computing power, as well as this linked to the power imbalance, so a centralization of data and power, because the data and computing power is so much that not everybody can afford it. If you go to the next slide, Sarah, I would just to zoom in into three key AI ethics issues that I mentioned already. So the privacy issue, the data privacy. Usually when we receive a service based on AI and technology, we would like to be reassured and convinced that data privacy is supported and protected. We also want to be treated fairly, so that's the issue of the fairness. And this, fortunately, in some domains, this is also protected by regulations at this point. And usually we would like to understand why we got a certain outcome. So explainability, fairness, privacy are really central in everything we get out of an AI service, especially if it has to do with something that is really impacting our life. If you go to the next slide, I just put one example, like we applied for a mortgage, and the mortgage application, assume it has been denied. So the first question is why? Why did I have that outcome? Which features of the input mostly influence the output? So definitely the explainability of AI and of the human decision maker that uses possibly an AI system to make that decision needs to be in place. But the explanation should not just say why in a very in a way that I cannot intervene. So it should be an explanation that also helps me understand what can I do about it? How can I change in my application in a way that I can get a positive outcome? So what are the causal relationships that allow me for intervention in my features and possibly future of success and positive outcomes? So explanations based on causal relationships. The second question, as I said, is, but have I been treated fairly? I mean, they denied my mortgage application, but is everybody in my situation with my gender, my age, my possibility of repaying the bank being treated in the same way? So all else being equal, a different value for one of the protected variables like age, gender, race should not lead to a different outcome. So fairness is very important, but it's not clear exactly in general what being fair means, because in every application scenario, whether it's a mortgage application or in healthcare or in other domains, one may consider different notions of fairness. For example, one could consider to be fair only the fact that there are similar accuracy rates for different groups, or also similar false positives and false negatives. So depending on the particular scenarios, there are different notions of fairness that could be the ideal notion there. And so when the system is built, we need to be able to make sure that it goes towards that notion of fairness that is specific and appropriate for that case. Of course, many things can cause a system to not be fair. The data set, the training and the test data set that may contain an imbalanced amount of data, for example, about different groups, or the choices during the design and the development, or even the deployment phases. As I said, these questions are questions that are usually asked by people, clients of a bank, for example, that receive a negative answer to their mortgage application in this example, but not just by people. Fortunately, there are also the external auditors and regulations that require that some of these questions are addressed in a comprehensive way and in a satisfactory way, especially when we are dealing with a high-stake domain. So, for example, in Europe, the future so-called European AI Act will make sure that if AI is used in the healthcare or in the HR domain or in other high-stakes decision domains, then all these questions and many others that define what is called in Europe trustworthy AI are addressed in a satisfactory way. If you go to the next slide. So AI ethics is just a very multidisciplinary field of study that includes AI experts, but also philosophers, sociologists, economists, and many other experts of other disciplines, whose goal is to take the best out of the AI technology and reduce the possible negative outcomes. AI ethics creates solutions to address the issues that I mentioned, and these solutions are not necessarily only technical. In fact, the technical ones are important and fundamental. So how to design and build AI system that follow our values in impacting in the life of people and societies, but also non-technical solutions that Sarah also mentioned that have to do with standards, audit systems, certifications, best practices, guidelines, principles, and many educational modules, playbooks for developers, and many other things that are not technical, but they need to be developed together with the technical things to really address the AI ethics issues. If you go to the next slide. So AI ethics has been around for a while at this point, since when AI started to be really very pervasive and impactful in our society. Of course, technology ethics was around for much longer, has been around for much longer, but AI ethics is really started, let's say, around 2015 or a little bit earlier. And I would simplify this history of AI ethics into three main phases. The awareness phase at the beginning, mostly in a multidisciplinary and academic environment, where the issues were started being identified by different stakeholders. Then the principles phase, where everybody published principles, corporations, government, academia, civil society, multi-stakeholder organization, principles that described how we wanted to position ourselves in front of these AI ethics issues. And now we are in the practice phase with regulations, standards, corporate directives, processes, and as I said, many other tools and many other solutions to the problems. If you go to the next slide, this is just a picture, a visualization of the more than 100 sets of AI ethics principles that were published up to 2019. So now there will be many more to be shown. And this was a result of a project at Harvard called the Principles AI Project. And here you can see that each ray of this circle is one set of principles published by one entity. The main themes are overlapping a lot, but each entity has its own angle to look at AI ethics, and so defines its own principles that are possibly addressing with different priorities the different issues. But just to say that really there are a lot of sets of principles, and it's time now to move forward from the principles to the more practical and concrete actions to be aligned in practice with these principles. If you go to the next slide, here I just give you a few examples of the practical phase of AI ethics. As I mentioned, governments are playing their part by, for example, in Europe, the EU AI Act that I already mentioned, that uses a risk-based approach to regulating AI applications. So it doesn't want to regulate AI technology, but AI, the applications of this technology, and regulating and putting more obligations to applications that are more high risk than others. It introduces 4 levels of risk, from unacceptable to high to minimal to none, and it gives obligations for both providers and users of these AI systems. The other example that I give is standard bodies, and here I mentioned the IEEE, professional organization that has put together a series of 15, I think, standard working groups, the P7000 series, that are all devoted to address one of the AI ethics issues, and some of them are being completed, so there are standards now, and some others are still ongoing. Another example are companies that use or produce and provide AI solutions. And for example, here the IBM approach, which is the company where Sarah and I work, that as an example, that includes risk assessment processes for everything that goes out of the company, developers playbooks to tell our developers how to build the AI system in a responsible way, software tools, but also education models and governance frameworks like the internal AI ethics board. And then the last entity that I mentioned are educational institutions. The next generation of AI developers and researchers need to be educated to understand what these ethics issues are and possibly innovate AI in a way that takes care of these issues. And here I just mentioned from a recent article a list of courses, but there are just 16 here, but there are hundreds of them at this point that help technical students to be aware also of these AI ethics issues. If you go to the next slide. This is just an analysis that was done recently in 2 years ago at this point on the impact of AI on the Sustainable Development Goals. Of course, AI can be used, and I mean, I don't want to go into the details. AI has been used to be beneficial in advancing some of the targets and some of the Sustainable Development Goals, but it can also be used to detract, and sometimes even non-intentionally, because by advancing towards one of the goals, it can also impact in a negative way on another goal or a target for another goal. So this is just to say that really the relationship between AI and the Sustainable Development Goals has been very active and been studied and evaluated as well. If you go to the next slide. So here are some lessons learned in AI ethics. So first of all, that it's important to work in a multi-stakeholder way where all the voices of the impacted communities are considered. That principles are very important, is an important first step, but they're not sufficient. That companies that use or develop or provide AI should be transformed completely, not just have an AI ethics team, but become a company-wide ethics company. That technical solutions are important, but they should be put together, should be combined with many non-technical solutions. That ethics is really a process and an approach, is not just a checklist or something that has to do with compliance. also that ethics solutions are not at odds with technological innovations or business expansions. The two things can go hand in hand, and it is really a process that is ever improving with mistakes that are, considered and addressed and so on. Let's go to the next slide that tells us, again, some of the issues that are related to AI, but also neurotech. So data issues. These are expanded definitely when with the convergence of AI and neurotech, because of course, neurotech is going to deal also with additional data that is the neurodata. The next slide, we go fast here, is about explainability. And this is also an expanded concern when AI converges with neurotech, because we know less about the impacts of this technology on our nervous system. So the trust for this technology is really an expanded concern, and also the explainability part. The next slide is about accountability. Still, neurotech is immature. AI is also immature for some respect, but neurotech as well. Maturity also of the devices, the interfaces, the sensors, and limited expertise in their interpretability of the neurodata. So accountability is an expanded issue when we put together AI with neurotech. Next slide is about fairness and access. Is again expanded because neurotech, as Sarah said, has the ability to act on data that come from our nervous system and that we may be unaware of or not in control with. So that can lead to discrimination, because discrimination is also something that is related to our unconscious thoughts and biases, and the potential to augment human beings with and not just remake something that humans could not do anymore, with implication for exacerbating inequity. Next slide is about profiling and manipulation. More data, more private data can be used for both these purposes. So an expanded issue here as well. Next slide is about impact on society, of course, more applications when AI and neurotech are combined. So more implications for everything we do in our society. Next slide is about privacy, and this is obviously very expanded because the technology now gets access also to our neurodata, and so mental privacy is an important issue besides the privacy issues that we have already with biometric data and many others with AI. Next slide is about human autonomy and agency. As Sarah said, neurotech can also write into our nervous system, so influence our minds more directly than AI. Often in real time, so an expanded issue as well. Next slide is about human identity, and this is definitely expanded because AI has access to some data that refer to our identity, but in an indirect, external way through proxies, and can influence our identity in that way indirectly. But neurotech can also do it in a direct way, and also in ways that we are not yet able to control or to measure. Next slide is about accuracy. We have less knowledge about the nervous system, so we may not interpret well the data that comes from the nervous system, leading to a lower level of accuracy. Security, of course, dealing with more private, more sensitive information can expand the security concerns of using neurotech together with AI. Next slide is about well-being, expanded concern again, because physical safety, of course, is introduced more than the safety that issues in AI, as well as some in invasive approaches, use of chemicals or materials that can be even toxic for our body. The next slide is about the fact that, well, AI people and researchers are compared to neuroscience and neurotech experts, they have a different history and they have different educations. Neuroscientists have been familiar for a much longer time with human and animal data and experiments and dealing with thinking about research ethics, much more than AI researchers and developers that use human data, for example, to train some AI systems, but only lately started to consider the ethics implication of the use of this data. And on the other hand, AI researchers had to be very fast in reacting to widespread and very fast applications of AI and building the best practices to mitigate the risk, to go from the awareness to the principles and to the practice very fast history that I mentioned of AI ethics solutions. The next slide is a call to action for everybody, AI, computer science researchers that are in the audience or even beyond. If you go to the next slide, is about that we need to be prepared for this convergence of AI and neurotech. There is already deployed application that show that, but more will come. And we need to be prepared technically to embed AI in neurotech systems in the right way, but also ethically, because of all these new and expanded ethics issues that we mentioned. We need to learn how to update the values, the principles, the frameworks, the tools, to involve neuroscience and neuroethics experts in AI ethics venues, and also to engage with those people that are most likely to be affected even in a disadvantaged way, like neurodiverse individuals and communities. If you go to the next slide, Sarah, these are two relevant papers that Sarah and I wrote. One of them is published already in Neuro that really try to expand on what we told you during this talk. The other one will be published on Communication of ACM next month. We'll thank you for your attention and we welcome any question or discussion in the chat.
Thank you very much, Francesca and Sarah. That was a really interesting overview, both of neurotech in general, AI ethics, and their convergence. I think we could probably talk for a long time about this, but maybe first, before we move on to the neural network, where you can kind of discuss one-on-one with people, I will relay some of the questions from the audience, one of which was, what did you mean, Sarah, by human agency and human identity? And I think, Francesca, you touched on it later as well, but either of you feel free to elaborate.
Yeah, it's a good question. And it's, as we have been discussing this internally, it's like something that doesn't necessarily always translate between languages as well, which we acknowledge. But in terms of agency, it means really being able to make decisions and have control over our bodies and our minds and our decisions. And identity is something that's really widespread. What we were talking about is identity in terms of selfhood. So like that, who you are, that this is your body, that this belongs to you. So like in the example I think I gave for the deep brain stimulation, there has been some research showing that sometimes people don't, when they are being stimulated, they don't know if what's happening to them, the changes that they are feeling is because of themselves, or because of something that is with the device, is with the underlying condition that they have. And so there's this mix of identity and then other aspects of the device. I hope I answered that person's question well.
Yeah, excellent. Thank you. I think I will ask just two more questions from the audience, then we can head on over to the neural network. The second question is, what are the parameters for ensuring fairness and inclusion in AI, considering that they are subjective? I guess maybe how do you define them across different cultures and whatnot?
Well, not just across different cultures, but also, in different, as we said, decision environments. Really, sometimes it's enough a notion of fairness that just looks at the same accuracy, more or less, for different groups. Sometimes that's not enough. You also want to make sure that the errors that the AI system makes, and in particular the false positives and false negatives, are in proportion in the same way across different groups. So depending on the various scenarios, for example, you may have more false positives or more false negatives for a different group, but maybe it doesn't really matter in that scenario that you have these differences. But in other scenarios, instead, it can be very important for ensuring non-discrimination among groups. So it really, a recent well, at this point, not so recent tutorial on fairness was listing 21 notions of definitions of fairness that are appropriate or not in different really scenarios. So that's why when an AI system is built, the first thing would be to understand where is going to be deployed and in which decision environment, because that will, and the consultation with the impacted communities and the client of that is going to use it is going to determine which notion of fairness is the best one. And then once you know the notion of fairness, then you can start to detect and mitigate bias in the data or in the model of the AI system in order to move towards that specific notion of fairness. So it's not, unfortunately, it's not just among culture, which is already differences, but also, in the different decision scenarios.
Excellent, thank you. And as I think this is a good maybe last question, as you're both working at IBM, one of the audience members is asking and saying, I'm very interested in the IBM approach to AI ethics. Could you please share some resources? And maybe I'll tack on to that any experiences, best practices that you would maybe recommend to other companies based on your experience and research.
Yes, so first of all, I mean, we didn't mention here, but of course we can share links to the AI ethics website of IBM that gives a very high-level description of our approach. But as I mentioned during my part of the talk, IBM has chosen to have a centralized governance approach to AI ethics, where the AI ethics board as representatives from all the business units that get together very often to define the best practices, define the education of how to educate our developers and everybody else in the company, and to really put together a company-wide approach. That's the best, lessons that we learned. Two main lessons that we learned in our journey at IBM. One is that it has to be a company-wide approach. It cannot just be an AI ethics team in one division of a company. And the second one is that for a tech company, it may be very natural to say that these are tech issues and can be solved with additional tech solutions. But in fact, it's easy to see as soon as you develop these tools that are very useful, that you also need to combine them with many other collateral but fundamental approaches, which have to do with education, with training, with design thinking sessions, with the diversity in teams, with the playbooks for our developers, with risk assessment protocols, and the governance as well. So a lot of dimensions that needs to be around the tools that the developers will use.
Excellent. Thank you both. Maybe on that note, we'll wrap it up here on this part of the session, and we'll all head over to the neural network. There are some more audience questions, and to the audience, feel free to continue asking, and the speakers will answer as many as they can in the next 15 minutes or so. And so thank you very much, Francesca and Sarah. That was a really fascinating session, and I'm sure there's lots more to come, and we could revisit this topic in a year, 6 months, and things might change. So it's very dynamic and interesting. And thank you everyone for joining today. Stick around for the neural network networking session, but of course, after this session is over, you can rewatch this at any time on the neural network by clicking the on-demand button, or anytime as well on our YouTube channel. Feel free to share this session with your family and friends. So like I mentioned, stick around. Francesca and Sarah will join you soon in the neural network, and we hope to see you next time.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. After the networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.